a container ship is being unloaded at a port. A light, inextensible wire cable is passed through smooth pulleys at P and Q and is fixed at R. The angle the cable makes with the horizontal is alpha at points P and Q. The wind is blowing with a force F away from the quayside, and to counteract this, a wire is fixed to the container at S and then fixed to the base of the crane at T. TS makes an angle beta with the horizontal. Given that the system is in equilibrium, write down the equations for the horizontal and vertical equilibrium. B, given that M is 2,500 kilograms, F, the wind force is 60 newtons, alpha is 45 and beta is 60 degrees. Calculate T1 and T2, giving your answers in exact form. So, looking at the diagram, here we've got the crane. Here we've got the crane. And we have the ship here and the container being unloaded. The cables pass through this pulley here and this pulley here, but fixed at this point here. There's a wind blowing here, F newtons, and the container has a separate wire going down to the base of the crane, which makes an angle beta with the horizontal. So first draw a force diagram of the system. So here is the diagram of what we just talked about, P and Q. So P and R and Q, these two are pulleys. This one is fixed. The wind blowing here, the weight of the container acting downwards, mg, and the rope being held by a tension T2 here to the base of the crane. So the system is in equilibrium. So resolving horizontally, so we're resolving this way. So we're going to have T1 cos alpha, which is this one here, T1 cos alpha, plus F, because F is actually acting in the same direction, in the positive direction, minus T1 cos alpha, because this one here, acting in the opposite direction, minus T2, cos beta, so this one here, this force here, this component here. Obviously the T1 cos alphas will cancel, that's equal to 0 because it's in equilibrium. The T1 cos alphas will cancel out, so you're left with F minus T1 2 cos beta is equal to 0. We'll call that equation 1. Resolving vertically, so this way now. So we got T1 sine alpha and another T1 sine alpha from there, minus the weight, because that's in the opposite direction, and minus T2 sine beta of this one acting down here from this rope here, that component there. So that's going to give me two lots of T1 sine alpha minus mg, T2 sine beta is equal to 0. We'll call that equation 2. Now we're given some information that M was 2,500 kilograms, F was 60 newtons, alpha was 45 and beta was 60. So from 1, this one here, we're going to have T2, rearranging it, cos beta is equal to F, taking that over there, and then that T2 will be F divided by cos beta. So T2 will be F, which is 60, divided by the cos of beta, which is also 60. The cos of 60 is a half. 60 divided by a half is 120 newtons. Keep the diagram there for clarity. Same information again. M is 2,500, F is 60, alpha is 45, beta is 60 degrees. So from equation 2, which is 2t1 sine alpha minus mg t2 sine beta is equal to 0. Then 2t1 sine alpha is equal to mg t2 sine beta. So t1 will be mg t2 sine beta divided by 2 times sine alpha. Right, so it's going to be 2,500 times g. We're asked to give it an exact form, so we leave g in the answer. T2 is 120 newtons from the previous part of the question. So it's 120 times the sine of 60 divided by 2 times the sine of 45. So 120 times 2,500 is 3,000. Sine of 60 is root 3 over 2, so we get 300,000 root 3 over 2 times g. The sine of 45 is root 2 over 2, so we're going to have two lots of root 2 over 2. This 2 here will cancel with that, so we get 150,000 root 3g. This 2 here will cancel with that, so we end up with 150,000 root 3g over root 2. Rationalising, so whatever this is, we multiply by it, root 2, divided by root 2. So we're going to get root 2 times root 2, which is 2. 150,000 divided by 2 is 75,000. Root 2 times root 3 is root 6. And we've still got g, Newton's answer given in exact form.